Good evening, everybody. I think that's it. So I don't see any more people joining, so we'll start the session. I'm going to share my screen. Please let me know if it's visible. All right. So is week four visible to you? Let me also log into my mobile. Okay. As usual, let's use the chat box to give in your answers. So before I begin this class, I think somebody already sent a message. Thank you, Arshia. So I guess or I believe most of you were there for the previous week's session. Unfortunately, there was a mishap and my recording was not complete. Therefore, I have to re record last week's session and post it on YouTube in case any of you is following the channel. And there was one more mistake in Needleman Wunsch matrices that we were doing. But since I'm going to be doing week three again and posting it, we did a blast, remember? So at that time, something happened to my system and it stopped recording the session. So I will be redoing the answers for week three and posting. So at that time, I'm planning on having an extensive explanation of. It's all right, Kiran. Anyway, I'm going to post the video. I was supposed to by now, but I had some pressing important work that I couldn't sit with the course again. So I hope. I mean, this is the place where it shows its recording. Therefore, I need to keep a track on it so that at least I can post this week's content on time. And week three will come as soon as possible, within a day or two, I hope. All right. So two things. One, Needleman Wunsch. I think I can show you on the PPT. Feel free to use the chat box to type in anything. So before I begin, so if you remember last week we started with writing the sequence on either side. Although the process is the same, I made a mistake in initializing. Right, when you initialize this values, I had to leave one more gap. I made a mistake here again. But you have to go with increasing gap penalties, increasing multiples of gap penalties. If a penalty of -2 is applied, then it has to be -4 and 6, right? Yeah, somewhere I had made a mistake and wrote 2 everywhere. I think I have to check again. I also lost the markings on the PPT. My laptop was in a very bad state last week, so I will rectify that and I'll be posting another video or the first video for week 3. Meanwhile, I wanted to show you all one resource that I found. This is for the question that somebody had asked, is if e value can be 0. It is practically impossible for it to be 0, but you can round it off to 0. As we said, the as and when the confidence increases, uh, oops, Yeah, this is the link. I will also be posting this in the description of week three's video, but I thought I'll share this with you today before I forget. Right. So this is something I found online where you can instead of manually doing it. Of course, you should do to get a feel of things. But if it's a longer sequence and if you're thinking or making a mistake, you can always correct with this. But the path of tracing can be different. I don't want to sit much on week three's topic now because anyway I'll be doing a separate video. So somebody had asked me about tracing the pathway back to the start. I mean, how do you align the sequence after you are done with scoring the matrix, right? So we'll look into all of those in the video, but for now I'm going to start with week 4. All right. So I welcome you all once again to the fourth week of live interaction session for the course Bioinformatics, Algorithms and Applications. And I'm Lavanya N, a PhD scholar at IIT Madras, and I'm going to take be with you in this session. All right. So practice questions are on the topic phylogenetic trees, part 1 and 2, protein sequence analysis, part 1 and 2, hydrophobicity profiles, patterns, and PSSM profiles. Okay. So for the first question, a dash indicates the hypothetical common ancestor or ancestral lineage of a tree. Your options are A. Unrooted tree, B. Rooted tree, C. Rooted and unrooted trees, and D. None of the above. Thank you, Rohini and Hitesh. All right. Anybody else wants to add their answers along with? Great. So we're all clear on that, right? A common ancestor is from where you branch out into other evolutionary relationships, right? Although this is possible with rooted trees, in unrooted tree we do not care about the origin or the common ancestor. It's not based on that. It is how related the organisms are based on their sequences, right? So it kind of stars out in all directions, irrespective of where the common origin or ancestor is. The right answer is D. It's not unrooted, not this, not this. Question 2. Which of the following methods is used for constructing phylogenetic trees? Thank you, Nagamani. Any more answers? I mean, we of course know UPGMA is there, neighbor joining is there, but I don't know if maximum parsimony was not touched upon in greater detail as far as I remember in the lectures. But this is also another method of constructing a phylogenetic tree. In fact, a very good method to construct a phylogenetic tree. So, all of the above is the answer, as all of you have pointed out Rohini, Savinder, Hitesh, and Nagamani. So I've just included a small piece of information where these are just images from Google, just to say that maximum parsimony is another method of scoring or relating two sequences, and it works on the most parsimonious explanation. Parsimony is when you're very stingy, or when something has to be done with the least amount of effort or energy or money, and it goes by the Occam's razor, which is a common it goes. The theory is such that if you have multiple hypotheses, the one that makes the least assumptions is the one that is closer to truth. All right. So it's just to show you that it is one of the, most of you might already be aware that maximum parsimony is one of the methods. Yeah, maximum likelihood is also there, but this was, I don't think he touched upon parsimony. That's why I thought I'll put a small slide here. See, pick a tree whose cost is the least. Cost we are talking about the evolutionary cost, right? How many residues are we changing? How many amino acids or how many nucleotides are changed in order to get a particular node? So the least possible tree topology calculate parsimonious cost and involve filling the inner node such that there is minimum number of substitutions. Or the parsimonious, yes. Anyway, you have the spelling there, right? Question 3. Dash is a program to construct a phylogenetic tree for a given set of amino acid sequences. This is a very straightforward question. Thank you, Hitesh. That's it. Okay. I mean, obviously, it's not PDB or FASTA blast, it is PILIP, right? All right. Question 4. What is the residue pair preference percentage of PE in the given sequence? Take a minute. Thank you, Devangana. Others? Option A 20, option B 10, option C 5, and option D 2. Nice, Hitesh. Any more answers? So, what is the formula? Great, right? So, what do we have here? P and E. How many times do they occur? P and E. There's one more P and E. That's all, right? So 2 into 100 divided by how many P's and how many E's? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 20. So what would happen if I change the question to Let's say PT. Just type in the answer because I don't know whether it will fit within the options given here. I haven't calculated myself. Use the same formula. Summation of number of PT into 100 divided by, are you sure, Debangana? Number of P plus number of T, which will be, so how many PTs do you have? Okay, Hitesh, let's check your answer. 100 by 7 it seems. Okay, so we have number of PT is 2 into 100 divided by number of P's is 5, right? Last time we calculated 1, let me be sure, 2, 3, 4, 5, right? And T, I don't think there are any more T's than these. So 5 plus 2, which is 200 by 7. 28.57. Nagamani and Hitesh have it. Great. 28.57. Thank you, Savinder Kaur. Clear? Okay, let's go. Because I felt P was there both in the lecture as well as here. So I wanted you to think. See, suddenly you thought it was the same, right? Devangana? Because you have to remember that the denominator also changes. Okay. Oh, sorry, Hardi. Okay. Question 5. Dash is the plot of hydrophobicity indices of the residues against their sequence numbers. What is the plot of hydrophobicity against sequence numbers? Not dot plot, not none of the above, not a pattern profile. Therefore, it is hydrophobicity profile. Right? I'm going to check if I'm still recording things. Please don't mind because I don't want to re-record. Right, it's still going on. Okay. Moving on to question 6. PSSM stands for option A, point specific scoring matrices, option B, position specific scoring matrices, option C, position specific scanning matrices, and point specific scanning matrices. So it is scoring, right? It's not scanning. Therefore, you can reject these two options. Is it point or position? PAM only has points accepted mutation, right? PSSM is position specific scoring matrix where you give weightage to the position. Okay, question 7. The molecular weight of the peptide LEYGQE is. Should I change the question? I mean, actually, from this week and what you're having now, these are different. But I think you guys jumped at the answer options. That's all right, Savinder. You can calculate again. So LEYGQE. This is K. Don't fall for this. Okay, Hitesh says C. Oh, I'm sorry. Hardi, right? Sorry. Any other answers, guys? Leucine is L. Aspartic acid is E. Glutamic acid with C. Acid is E. Phenylalanine is F. Glycine is G. Asparagine, glutamine, arginine, serine, threonine, tophanin, tyrosine. Right? So L is 125, E would be 150, Y is 175, G is just 70 because the smallest amino acid, right? Q 140 and E again 150. So first let's sum these up. 125 plus 150 plus 175 plus 70 plus 140 plus 150. So this gives us 810. So shall I go with option A? No, right? That's correct. Yes, Rambala, but what do we know? These are molecular weights of individual amino acids. But when you have two amino acids, what is it? Okay, thank you, Rohini. So you have NH2 on one side, COOH on other side, R group and H. So when two amino acids come together, they are forming a peptide linkage, right? So COOH and NH2 of the next amino acid, you take one of the hydrogens there and water is eliminated, which has a molecular weight of 16 plus 2, right? So for each, when you have 6 amino acids, a peptide of length 6, there are going to be 1 2 3 4 5 peptide linkages. So 5 times water is getting eliminated. So the formula goes sum of molecular weight of each of the residues minus, correct Nagamani, n minus 1 into 18. This is to account for the water. So what do we have here? 810 minus, what is n? 6. 6 minus 1 is 5 into 18. 18 5s are 90, right? Yeah, 810 minus 90 would give you 720. The answer is the same as your current week's assignment if most of you have gone through it. But the question is different. Alright, great. Question 8. The hydrophobicity profile of which window length is the smoothest one? Option A 1, option B 3, option C 9, and option D 19. answers. Just try one. It can be wrong. It's okay to not know. Just take a wild guess. Okay, thank you, Savinder. Nagamani says B. Hadi says B. Hmm. Oh, Hadi says D. Nice. We have three different answers. Any takers for C? Okay, we have one, one. Thank you, Devangana. And one more on A. Nice. So, what does hydrophobicity profile look like? She also says D. So, our options are more votes are there for A and D. These are the competitors now. So, I'm going to skip B and C for now because it's either the lowest value or highest value by the pulse of the audience I'm seeing. Okay. So, you're going to see the hydrophobicity. I mean, it's going to be plotted against the sequence number, right? Now, if there is no window, which means it is 1, right? When the window length is 1, you are actually not grouping anything. What do you mean by a window when you have a sequence of so many residues, say uh, a random sequence? Okay, and I'm going to, let's say I have no clue which how hydrophobic they are. I'm just plotting random points. So how are they going to look? Very messy, right? And with increasing amino acid length, or the as and when your protein sequence length increases, you're going to have multiple rugged points like this. It need not be always zigzag. I can have multiple here and some here, and but it's a very messy going profile, right? Now when I'm choosing a window length of 3, it's going to see group the sequence in multiples of, or as blocks of 3, right? So then what happens, it is going to average the hydrophobicity score for those 3 sets, all right? And you are going to, for first 3 or next 3 or the other 3, you're going to have a common score, and based on those averages in between, and the window can also move. When you call it a window, it's more like a slider, right? So based on that, it is going to alter a little. It might be a little rugged, but you will have a more discernible profile. This is in case of it is 3. If it is 9, you're going to have a greater window where within that window it may be little wavering because of the differences in amino acids in that 9 residues. But overall, it is going to be, you'll be able to see a better trend of what is going on in a particular stretch of amino acid residues, and you can see patterns more easily. With increasing amino acids, if you have 1,000 residue protein, it will be very hard to get gather or understand a pattern if you have a window size of 1 or 3 or even 9. So that's when you 19 comes in handy, where, or even if it's a 500 residue or 200 residue protein, you will have the smoothing happens more with increase in size of the or length of the window, right? So option D is the right answer. Hardi and Arshia got it right. Good that all of you gave a random guess. It was nice. So you go with option D as the right answer. I think I skipped question 9 probably because it already got repeated in current week assignment. Question 10, for the alignment of DNA sequences given below, what is the value of G at position 3 in a weight matrix? So we are talking about an alignment score in a weight matrix. What is the value of G in position 3? 1, 2, 3, 4, 5, 6. This is the column you are looking at. Take a minute. I'll just be back. You can see the question and work on the answer. Type in the chat box. I'll be back in. Okay. Hadi has answered. Anybody else? So what is the formula for? Am I audible by the way? Okay. Back to. So what do we have here? You have 3 G's out of 4 sequences. Right? How do you score this? Ln of it's a very poorly written formula. So I think in the lecture slides, the ln was not given for the entire numerator and denominator, but the calculations were all right. Just saying, if you're going by the notes or copying from the slides, you need to be careful. So the in the formula that was there in a printed format, that was right. Ln was there common for both the numerator and denominator. So follow that. So number of I is here we are talking about G, right? So Ng plus probability of G. So this is a nucleotide sequence, right? Nucleic acid sequence. So probability of any A or G or T or C would be 1 in 4, which is 0.25. If it were a protein sequence, probability of any of the GA, VL, dot till Y is 1 in 20 amino acids, which is 0.05. But here we are looking into this case of nucleic acids, therefore Pg will be 0.25 divided by, what is N? Capital N is the number of sequences. You have 1, 2, 3, 4. This is N. So N plus 1 would be 5 whole divided by P of I is again 0.25. So let me substitute. Number of G's is 3 plus 0.25 by 5 divided by 0.25, and you have ln here, don't forget. So what is 3.25 divided by 5 is 0.65, divided by 0.25 is, sorry, 0.65 divided by 0.25 is 2.6. So ln of 2.6 is 0.955, which I am rounding it off as 96. So Hadi is right. I hope everybody else understood how this is done. Cool. Shall we go on to the next question? You can take one more if you want. We can take T here on fourth row. So T, number of T's is 2 plus 0.25 divided by 5 whole divided by 0.25 ln. What is 2.25 divided by 5? 0.45 divided by 0.25 is 1.8. Ln of 1.8 is equal to 0.59. Okay. So the alignment score of something that has just 2 positions is lower than something that has 3 positions. Okay. Let's go to the next question. Okay, here comes the current assignment which I've already done. So now you all can jump in to answer. The question is different. Note that. Thank you, Savinder. Thank you, Hardi. So you have E here. Then for L, go for, there is E. Oops, why do I keep making this? This is D. Yeah. So we have covered E, A, we have covered D, is R. Alright. So sum this up. 85, 130. What is A? 85. Oh, oops. Where did I start? Where is L? 125 plus E is 150 plus A is 85. D is 130. E is again 150. R would be 170. 125. So this is for people who did not solve their assignments. So 810. Again, this is a sequence of 6 residues minus 5 into 80, which will again be 720 as we saw previously. Thank you, Nagamani. Okay, moving on to question 12. Identify the amphipathic beta strand in the sequence AAKVTABAATSI. I see a lot of A's coming up. 3 votes on A. So let's first score each of these. A, I'm giving 1. It's the same scoring that we had used in lectures. -2. B is +2. T is -1. And A is again 1. So what does that give us? -2 and +2 cancel out. -1 plus 1 cancel out. 1. A, K, V, you have 1, 1. K gives -2. And V is +2. Gone. Then AVA 1, 2 on 1, which is 5. And the last, I'm just writing the hydrophobic score alone. V is 2 on 1 -1, 4. But if you notice, oops, so when I'm cancelling, these are at different positions, right? And the reason I'm not drawing into, sure, Rambala. Okay, if you guys are ready to listen to a long explanation, then I can draw it into a hydrophobicity index. But visually, when you see, you have a positive, negative, positive, negative, positive. Here you have two positives, one negative, and a positive. Relatively, this should be your second best option. Okay, and also notice that the sequence length varies. 2 and 5, it does not matter in this question, but if suppose you have some other question where uh, you have to decide based on the relative hydrophobicity, then you should keep in mind that the sequence length is also different. But here everything is hydrophobic. There is no amphipathic. Whenever you say amphipathic, it has to be both hydrophobic and hydrophilic, right? So let me take this as 0, -1, -2, +1 and +2, and A, K, V, T, sure, Samiksha, right? We'll take a sequence, and alpha and beta sequences are almost the same. You just have, in beta, you will have patterns of 1 on either side. In alpha, you will have twos. It can be like this or like this. So beyond, above and below the sequence, you will have 2 points going. This is for alpha helix and the other one is for beta. Do you have any specific questions, Amiksha? I can't hear you. Sorry. Did you say something until now? Yeah. So, okay. First, we'll finish this because this will give you a normal idea of what amphipathic we are talking about here. Okay. So, let's start with the first one, AKVTA. So, A is plus 1, plus 1, K is minus 2, okay. V is at plus 2, T is at minus 1, A again at plus 1, V at plus 2, A again at plus 1, plus 1, T at minus 1, S is at minus 1, I is at plus 2. Now look at this. So when we say amphipathic, it has to be both polar and non-polar. So you need to have an equal distribution of both these guys. And when you look at the question, the first option AKVT, A. So this is here. So between these, how do they look? It's going back and forth across the midline, right? So this is definitely amphipathic. When you look into option B, AAKV, and as I said, this is your second best option where you have, please excuse. So you have a tiny stretch of alanines followed by K, a polar residue, and again V, non-polar, hydrophobic. Okay, so this is also amphipathic, but you're better. It both these are amphipathic. If you're talking about only this criteria, option A as well as option B come into, how do you say, you can filter down or narrow it down. But as Samiksha asked, what is this doing here? What is beta strand's role here? We will come to that later. Let's just finish off C and D before that. Option C is AVAA. So this guy, AVAI. Look into these regions. All of them are hydrophobic, non-polar side chain residues, right? So it is not amphipathic at all. It is absolutely hydrophobic. When you come to AVAAT till here, right? So look at this region. Most of them, 4 out of 5, are positives for hydrophobic, and only the last residue is polar. Okay, again, this is not amphipathic, it is predominantly hydrophobic. Now, out of these two options, A and B, why do we choose A? Whenever you have an alpha helix, you will have multiples of two residues. Okay, you saw that I ranging from 1 to 4. This is I plus 2, I plus 1, I plus 2, and I plus 3. And j is in multiples of 0, 4, 8 till the length of the sequence, because each first residue pairs with the fourth, bonds with the fourth residue in a helix, right? That is why you see two of one pattern and two of the other. So you will always have couple of residues on either side. So this is what I think sir had mentioned as periodicity, right? It has a periodicity of 2 on either side. This is for alpha. Now when beta strands come into play, you will have, I hope this color is visible in case it's not. In beta strands, this J for beta is in multiples of 2. I'm not going into too much into the equations here, where you have summation of hydrophobicity Hij, H plus I plus J by N and all. Okay. The concept is that you will have alternating hydrophobicity between the alternate residues itself. So you'll have one point here, one point there, one point here, the next point there. So beta strands have a periodicity of 1. So when you look into AKVTA, when you think about this sequence, only in one region you have residues alternating with a periodicity of 1 in terms of hydrophobic index, right? So this is the region which accounts for amphipathic beta strand. Does that make sense? Samiksha, Rambala and others. Was this clear? Okay. So we can all agree that AKVTA is the right option. Let's go to question 13. For the alignment of DNA sequences given below, what is the value of T at position 2? Oh, I think this is exactly what we did, or similar question in the weight matrix. No, no, no. We did T at 4, right? So this is position 2. You're looking into this column. Thank you, Harti. Thank you, Nagamani. Meanwhile, I'll just check if I'm just paranoid about recording today. Yeah, okay. Okay. Anybody else? So how many t's do we have? So what is this? Ln of number of t is 0 plus 0.25, because this is still uh, nucleic acid sequence 1, 2, 3, and 4. Therefore n plus 1 would be 5 divided by probabilities again 0.25, right? So you have ln 0.25 divided by 5 again divided by 0.25, which is ln of zero point 0.2. Ln of zero point 0.2 is minus 1.609. Oh, this is plus, right? So option A is the right answer. Thank you all. Question 14. The plot of hydrophobic. Okay, this is absolutely redundant. We all know what this is, right? It's not pattern profile dot plot. It's just a redundant question. Question 15. UPGMA method is based on. Thank you, Rambala. Was that for? Okay. Mhm. Is it option A, number of mismatches between aligned sequences, differences in amino acid residues between sequences, change in hydrophobicity between aligned sequences, change in size between aligned sequences? Great. Most of you, I think all of you have said A. That's right. So the distance is based on number of. Definitely not this. Not this. How would you count the differences in amino acid sequences? I mean, amino acid residues. It is by the number of mismatches, right? You cannot quantitate the difference in amino acid residues without something to score them. And here, instead of scoring uh, each difference, we are first going with the mismatch. Well, that is the first distance based on which you develop trees. Question 16. Which of the following sequence seems to have a transmembrane helical segment? The options look very long. So I'm just going to first look for differences. All the others are conserved. T H D V S D. Okay, this is the only different guy. A P L B N. In this region itself seems weird, right? Okay, until here, not much of a difference. From here, we're seeing tryptophan. There are multiple ways to attack this question, but I'm going to look into, since it is transmembrane, I expect it to be hydrophobic and helical. Okay, so first I'm going to use the same scoring thing where you have ACG, and I don't want to sit and score each one of this. So I'm just going to look at residues. Another way to do this is paste the sequence on the browser and get the answer, but in exams you cannot do that. So it's better to visually attack this. So look for sequences that are rich in these and avoid those that have more of charged as well as polar residues. Okay, that said, I'm keeping my eyes open for ACG, MY, FIL, VW. Lots of A's, F, I, L, V, G. Oh, this is absolutely rich in hydrophobics, right? I'm going to look for only things that I need to eliminate here. P is weird, K not needed, 2 E's not needed, T okay, and H is there, and you have S here. Similarly, in the beginning, you have M, which is hydrophobic, T, which is polar, K again, L is fine, D little, T, H, D fine, problem, O, problem, fine, 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 fine. So when you see, you have a stretch of hydrophobic, polar, polar. So remember, you have a transmembrane helix like this, where here it is going to encounter the bilipid layer. So this is the stretch that has got to be hydrophobic, flanked by a little polar on the either side. So A looks really inviting to me. Before we fix things, I want to look into other options, right? R is bad, but D and R still fall in the same category. So really not much of a difference between these guys. So until here I can equate this with A. What happens here? Okay, you have one K in R. There's also a D and an S. Just a small stretch of hydrophobic followed by more polar guys. Hydrophobic, polar, hydrophobic, polar. This looks like a beta sheet actually. Then you have hydrophobic, hydrophobic, charged, hydrophobic, hydrophobic, charged, arginine again charged, great, great, charged, great, 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 not so great, problem, and so on. This region I don't care anyway. So I don't like. Yes, Aisha. After I'm done with this, we'll go back to question 13. But where were we? So I don't like B as such. Followed by, we're going to follow the same questions. This nice, nice, bad, bad, nice, nice, bad, bad, great, bad, bad, good, bad, bad, great, 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 GLAWY, good, 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 bad, good, bad. This is almost the same as A, B, S, T. Not very happy with this too because you have stretches of polar residues coming in between, which is not good for a transmembrane protein. You need to have a good stretch of hydrophobic. You have a nice stretch here, but it's not long enough. So I'm a little partial towards C. Let's compare D. Same stories. We'll quickly do this because I don't want some of you getting bored already. So, but I think you all get the drift, right? How this is done. This is similar to A here. Can you see? But in the middle, there's always I'm partial towards both C and D at the same level. You have interspersed polar residues. At least here you have a continuous stretch again, but there is no continuity in hydrophobicity in case of D. Both fall under the same category where there is no proper continuous stretch of hydrophobic residues, which will make life easier for a transmembrane helix. But on the other hand, you see here a stretch of hydrophobic residues, and even amongst these, you have the minus one category more than minus two, which is a good thing. Here it's fine. On either sides, you will have polar environment, so that's okay. It is the transmembrane region that you need to worry more about. So, given the options, I would side with A and not any other option. So, somebody asked for question 13. Aisha, you want to see the question or you want me to explain again? So, we are talking about column 2 here and ln of number of t plus 0.25, where this is probability of t divided by capital N1 plus 1 by probability of t. So this is ln of number of t is 0 plus probability of t is 0.25 divided by n plus 1 is 5 divided by 0.25. When you do it, it will be ln of 0.2, which is minus 1.6. Can I move Aisha? Okay, I'm going to continue. Question 17. The Newick notation for the following tree is. Thank you, Savinder. Are you sure, by the way? Do you want to reconsider your answer? Thank you, Hardi, Nagamani, Devangana, Tilza, Malini, Bala. Okay. Thank you, Savinder. Now I think everybody agrees on the same thing. Nagamani, do you want to change your answer? So what are the groups here? A and B are a group. Thank you. D and E are a group. C and F are separate. So look for that first. This is wrong. So 1, 2, and 4 give you that. Apart from that, you know D and E are a group. No other option gives you that. For those who are not aware how to write in Newick notation, you will put A and B separate, and then you have C, and then there's D and E, and there is F. These are not interrelated between each other, therefore they're all pointing to a common ancestor, therefore you don't have to worry who is inside whose bracket. Okay, otherwise we will need to worry about, if let's say C was here or something, you will have to put a brace around C including A and B and then continue with this notation. Right now, since here everything is separate and joining a common ancestor, apart from these groupings here, this is the Newick notation for the given question. Okay. Question 18. Bootstrapping is used for evaluating the option A accuracy, option B sensitivity, option C confidence level, and option D ROC. Okay, as all of you answered, it's not accuracy, it's not the sensitivity, it is for the confidence level. Question 19. Amphipathic character of amino acid residues in a protein sequence is based on. Great. We just discussed that, right? Of course, we are talking about hydrophobicity. The more non-hydrophobic it is, the more polar it is. But hydrophobicity does not determine the amphipathic character, right? It also has to alternate with polar characters. So occurrence of polar residues, yes. Occurrence of non-polar, yes. Occurrence of both is the right answer. Therefore, we have to disregard. And the periodicity of polar and non-polar characters of residues. Question 20. Phylogenetic analysis of protein sequences provides information about sequence similarity, evolutionary relationship, physicochemical properties, all of the above. This is wrong, therefore this is wrong. Is it sequence similarity or evolutionary relationship? We are talking about phylogeny, right? It's about how the organisms are related. Of course, it is determined on the basis of sequence similarity, but it provides information on evolutionary relationship. Therefore, option B is the right answer. All right. So with that, I think I have finished my questions for the week. But I would like to. Initially, I had shared a link, right? This one, I'll be putting it on the description of week 3 as well. but I'm sending it here again in the chat box so you can use it and try things today. Now I have copy pasted week three's question, this one. Okay. The best motif obtained by the alignment of sequences, these guys, we did it during the class, but a cleaner, more visible version. So I've pasted these. Uh, two is actually the first sequence in the question, and first sequence is the other way around. Okay, that doesn't matter. Now look at this. My screen is visible, right? So this was one of the mistakes I had made. I had put -2 everywhere, or I don't remember actually whether I did it in multiples of 2 or not of the gap penalty. The max score is 1, mismatch is -1, and gap score is -2. You can always change it here. You can either increase or decrease. And so they have generated the entire matrix. It goes all the way till -23 on this side and -21 on the other side. And if it were just gas, it will be -24. That's the maximum negative score you can obtain. Okay. So they're starting from -3 and going back. But this is just one path. So according to the question you can get here, 80-80 is the most aligned, or 80-80C. Until C you can have a good answer. Alignment. The best motif obtained is 80-80C. Not GAT80 or TAGCT, 80-80A. You can see it from there. Now what I wanted to show here is you can either increase. So when I have reduced the gap penalty, the alignment has changed. Can you see that? And even here I can clear the path and I can go with custom path, where you choose where to go. And as you choose, the alignment is starting to happen here. I'm just randomly picking residues with no reason. So for those of you who had a question as to how you need to choose a path, you can choose any path, but the score will correspondingly be horrible. I mean, the more you gaps you introduce or more mismatches you go for, it will be more negative. So, but you need to obtain a positive or the best possible score for a given alignment. So you need to think what will be the best way to align a sequence and go along with it. Now if you see, it is lot lesser gaps and better score than -11, right? So I felt this would help you get a head start into aligning sequences. I'm just randomly picking up things here. Okay, so let's say go like this. So this is another path. Now I can trace back to this point, and here I can go for, or at this point, and let's say go for this. So until here you see that I have a score of +3. Now I still end up with +1. You can always trace back and see the alignment. So I found this as a very nice resource somebody has developed and put it up for us to access. You can also change the mismatch scores, increase, decrease. I mean, you wouldn't give a positive mismatch score, that would be crazy. And see, everything is great in life, so that can't happen. So you have to keep it 0 or negative. And max score you can increase, gap score you can decrease, and compute optimal alignment will give you the one that gives the best score. Okay, manually I'll be doing the alignment and showing in week three's class. All right. So, is there anything else? And I wanted to tell you somewhere sir mentioned cladogram or something. So this is a whenever you have phylogenetic trees are also called cladograms, and this particular thing is a clade. I can maybe include a definitions page to help you all. Otherwise, then if there's anything, please drop in the chat box. Yeah, I think we have it covered. Question 3 of week 4, sure, Kritika. Week 4. You mean the current? Uh, Let me ask that. This question 13 or 3? Just confirm. This one. So, Kritika, stop me when you do not understand. So, for finding the score for the value of a particular residue or nucleotide in an alignment, what you do is look at here we are looking at position 2, A, G, G, G. There is no T here, right? In a question, we saw that G was in three places. So we gave it a score of or a frequency of 3 to start with, right? But in this case, frequency of T is 0. And the formula that you have here is ln of number of T's or the frequency of T's plus what is the probability of T. Now here when we talk about probability, it is what is the natural. If I have 1, 2, 3, 4, 5, 6 nucleotide sequence of length 6, what is the probability that T can be here in position 2? Now we have no clue what this sequence is or what is the order of nucleotides here. In general, if it were a blank space, what is the probability that the second nucleotide is T? It is 1 in 4. Thank you, Rikina. So 1 in 4 out of A, T, G, C, T is just 1 in 4 possibilities. So can I say that P of T is 0.25? Similarly, I can say P of A is equal to P of C is equal to P of G is equal to 0.25, where you have no clue what the sequence is and you don't know what is the most probable guy here. You from here you have information that G is the most possible Purin here. I'm sorry, pyramidon, right? Yeah, correct. But when you have no idea of the sequence, all four nucleotides have the equal probability of occupying this space. Similarly, if we are talking about uh, amino acid sequence, a peptide sequence here, okay, let us take three sequences. I'm just randomly writing. Okay, so at this position you find K occurring two times and R occurring once. But If we are talking about a sequence, a peptide of length 5 amino acids, the probability of any amino acid occupying this particular position, we are not talking about positives, we are not talking about negatively charged, no polar, no hydrophobic, no sulfur containing, nothing. For any amino acid to occupy 3 is, or 2 or 1, any position is 1 in 20. Assuming they all have an equal chance of being in that position, you are taking a probability score there. Okay, divided by capital N. Here is the number of sequences we are talking about. In this case, N is 3. In the question's case, N is 4. Right? Divided by. So what you are doing here is that you are talking about 4 sequences and you are essentially adding one more sequence. What would happen if I have a fifth sequence where T is possible? That is the concept behind doing this formula. Okay, you are just assuming another sequence where T is can occur in position 2. So you are also increasing your n by 1 divided by probability of T. Right? Now what is the answer here? Number of T's is 0 plus probability of T is 0.25 divided by capital N plus 1. Here according to the question is 4 plus 1, which is 5, divided by probability of T again. So what does that give you? Don't forget the ln. Ln of 0.25 by 5 divided by 0.25, which is nothing but you just any positions. Yes, you got it right. Just finish it up. You can just cancel these guys out. Ln of 1 by 5 is zero point 0.2, which is minus 1.6. Anybody else? Anything that I should repeat or wasn't clear? I think these were all easy questions. Okay, if there's nothing else left, thank you all for joining today's session. Hope to see you all next Friday too, between 6 and 8 p.m. Thank you, Rikana. Thank you, Hardi. Alright, I'm going to close down the session for today. Thank you all. Good night.